Hello students, welcome to IMS GATE Academy. In the foundation course, I started electronic devices and circuits. In the last class, I did the PN junction diode. In this session, I would like to start BJT, bipolar junction transistor. I hope every one of the students are going to enjoy with the subjects, no doubt. Understand that now. Yes, I will start the BJT here now in electronic devices. Bipolar junction transistor. Junction transistor. You can say BJT. We can put like this now. The gate point of view, or even in the PSUs, this topic is given much importance. But we are not going to discuss about the external applications of BJT. In electronic devices, only internal structure and parameters related to the what now? Internal part is to be discussed here now. That is more important. First of all, what is the importance of this BJT? Even it may be the external, certain points are required here now. Why bipolar junction transistor is required practically? It can act as an amplifier. For the sake of amplification of any signal, we need to use bipolar junction transistor. But electrical students, in the electrical engineering, this can be used. What device? BJT is used as a switching element. In ECE, it is acting as an amplifier. That application is taken. But in the power electronics, they are going to use this bipolar junction transistor as a switch, because it will work as a, it will work in cutoff mode, and also it can work in the what now, saturation mode also. But in electronic devices, but in ECE, this transistor can be taken in a mode of actual now. By using that mode only, we are going to operate only, we can say. The one of the doubt is generally it is going to arise. What doubt? Sir, a transformer also can boost the voltage. If I give the input voltage low, I can get the output voltage more. So even the high voltage I gave it, low voltage also I can get. So why I can't say transistor as a amplifier only? So sorry, the transformer as an amplifier only now. That cannot be taken here now. But amplification means we are going to give importance to the power. The power amplification, wherever it is done, that can be said as a what now? Amplifier only now. The BJT applications we can find the power amplification only now. But in the transformer, if it is taken, we can't find any power amplification. Voltage amplification is done. When the voltage is increased, current will be decreased, but the power is more or less same. But even the voltage is decreased, current will be increased, the power will be remaining same, even in the step up or step down only now. That is why we can't say the transformer as a amplifier only now. But the BJT can act as a amplifier only, we can say. But how that structure will be there? What are the elements? What are the regions are existing? How many junctions will be there now? How the supply will be connected? How the doping concentration will be made? Each and every point I would like to discuss. But we can draw the transistor in this way. But how many types of transistors are there? That point is very important at first. How many types of transistors are there? There are two types of transistors we know. One is said to be PNP transistor, second one is said to be NPN transistor. So I can write one is said to be PNP transistor, the second one is said to be NPN transistor. This can be said as a structure. It's not a symbol, it's a structure only now. This is given a name emitter, E. E indicates emitter. It is connected by how many electrodes? To watch 3 electrodes. This is said to be B. B indicates base. This electrode is taken as a collector. This is nothing but collector I can put here now. Here, how many junctions are there here? There are 2 junctions. 2 junctions we got here now. Junction 1, junction 2, I can put here now. I want to put this as a junction 1. This can be taken as a junction 2. I can put here now. This is the structure, I can say. This is structure of PNP transistor. I can say. If you have drawn NPN transistor, one more is nothing but the NPN transistor we know very well. That is drawn in this way. Structure we can put in this way only. But here, N type here the P, here N. This is emitter E, this is the base B, this is collector C. How many junctions are there? Means here also we can take same 2 junctions only. This is taken J1, this is taken J2. This can be taken as a structure of NPN transistor, I can say. NPN transistor only now. But what about the, what I can explain the structure? How many regions are had by the transistor? Whether it is a PNP or NPN, it doesn't matter now. 3 regions are there. One is a P, one is a N, one is a P. How many regions? 3 regions are there. But even in the NPN also we are having the 3 regions only. How many number of electrodes are connected for this PNP or NPN? 3 electrodes are connected. One is said to be emitter, one is said, other one is a base, next one is the collector we have again. How many junctions we are having? 2 junctions we are having. But in between P and N, 1 junction is there. Between N and P, 1 more junction is there. We are calling as a J1 and J2 only now. Anyhow, 3 regions, 3 electrodes and 2 junctions had by a transistor only now. We are saying here now there are 2 types of the transistor. One is a PNP, one is a NPN transistor. What are the majority carriers we can have in PNP transistor? What are the majority carriers we are having in the NPN transistor? Majority carriers means where you can say in emitter side only you need to take. Emitter side always you can have the majority carriers only now. Maximum concentration we can find there only now. I will discuss otherwise now. First, one more point I will explain that what now majority carriers and everything. Before that, one more point I want to explain. Sir, there are 2 types of the transistors you said. One is a PNP, second one is a NPN transistor you said. The students may ask a question like this now. Sir, when I can use PNP transistor, when I can use NPN transistor? That means based upon the applications we know that now. Based upon the application means what point we need to consider? Based upon the collector current only we can say which type of transistor is required in practical application. If you want to get the collector current of the more you think it's so, in that case we need to use the NPN transistor. NPN we need to select if you want to get the more collector current only now. If you want to get the collector current of less you think it's so, in that case we can use the PNP transistor only now. That means based upon that collector current we can select in practical application whether it is a PNP or NPN transistor only here now. Understand now. And how that symbol of the what now PNP and NPN transistor is to be drawn? We can say the PNP transistor we can draw in this way. The symbol of the PNP transistor is to be drawn in this way. This is the emitter, this is the base, this is the collector. This is taken as a PNP transistor symbol, symbol of PNP transistor I can say. Transistor I can say. Here it is given one arrow, arrowhead is given. That arrowhead indicates what now? The emitter current passes in which direction? The direction of flow of emitter current is indicated by the what now? Arrow given in the symbol only now. If it is a NPN transistor, you think it's so. That symbol is taken in this way. The direction must be reverse. But the direction always you must connect, you must put where? At the emitter only. At the emitter only you need to put only now. That's very important. This is emitter, this is a base, this is a collector. This is symbol of NPN transistor. Symbol of NPN transistor, I can say. Like that I can put the what now? Symbols of NPN and PNP only now. We can put such a way. But what about the width of the regions? What about the concentration of the what now charge carriers in the NPN or PNP transistor? I will give one by one here now. Suppose I selected, next one, I selected here a transistor structure like this. I selected here the transistor structure I have taken like this. Here I have taken PNP transistor for example. This is a P, this is a N type, this is a P type I have taken here. We connected with 3 electrodes. One is a emitter here, one is a base, one more is a collector, we know very well. The point what you have to remember, from here to here, I will give. The distance from here to here, I want to say the width of the collector region only now. Width of the emitter region, this one. This is the emitter region only now, this portion. The width of the what? This collector region, I wish to take it as a WC. W suffix C, I want to put the symbol. And this width, I wish to take it as a what not? WB. W suffix B, you can write here now. But these are the widths are maintained equal or unequal values. Each and every one is a what now? WC, WB, WE will not be same. Those widths will be changing only now. I say the collector region width is always maintained very, very large, far more greater only, practical parameter. The width of the collector region is maintained always very, very large as compared to the width of the emitter region. But the width of the emitter region is greater than what? Width of the base is possible. The finally, which width is very small? If I ask, anybody can say very easily. WB is very, very small, very thin. Then after WE is moderate. W suffix C is what now? Very large only possible. Sir, why such a way the arrangement is to be made? Why I should not take all the regions of equal size? The doubt is going to arise only now. Why the collector region is a very, collector region, why it is maintained very large means the power consumption here possible because the output current we are going to receive from the collector only now. Whenever you are receiving the collector current at the collector side, power consumption also more possible in the collector region only. When the power consumption of the more is possible in the collector region, the heat is going to develop more and more and more only now. That heat I want to dissipate. The power at the collector region, if you want to dissipate, means you need to arrange the width of the collector very large. That is must only. And second doubt it is going to arise. Why I should maintain the width of the base very, very small, sir? not small, very, very small only required as compared to the width of the collector region only now. Because when this width is, because of why this width is taken, base is required for the recombination of electrons and holes only now. Whenever the holes are moving from the p-type to the n-type, and but the electrons from the n-type to p-type, wherever it is done, the recombination is done. That means the recombination of electrons and holes where it is done clearly means the base only possible now. That means what now? Recombination, whenever it is done, that recombination rate must we have to reduce only now. We have to reduce the recombination. That means the number of the majority carriers from emitter to the collector must move more. When the holes comes to this side, some will recombine and maximum will go to the what now? Collector region only now, to develop the collector current now. When I want to receive the maximum number of what are charge carriers to the collector, you think it's so. Less concentration of the holes must be recombined with the what now? Electrons, the n-type material only now. That is why that width is taken very small only, we can say. That is a very small only now. And also early effect is the cause. According to the early effect, what we can say, whenever the collector region is a very small, base width is a what now? Base width is what now? Base width, but a collector region is a very collector region and base region. But suppose collector region is a small, I have taken for example. Catch my point. Collector region I have taken small, and also what I can say now, the base I have taken the large, for example. Base is a large I have taken. What's going to happen? Depletion layer is going to form between N and P this side. Depletion layer is going to form in the region of N and P only now. Wherever the what now region is a very small, there you can find the what now? Depletion layer very small. If collector region is a what now? Small, you think it's so. The time depletion layer is going to form here very small only now. At the time when the width of the what now? This collector is maintained same, moderate, suppose I have taken, that width will be increasing. Depletion width will be increasing in the base if you maintain more only now. Practically, we are maintaining the base is a very small. At the time, the width of the what now? Depletion layer, it is going to form, this side is a very small possible. But the width of the what now? Depletion layer, I want to form more. The time the region must be very big only here required. Then that depletion layer more possible, this side is small possible. In case this side depletion layer is increasing, you think it's so. The time what is going to happen now? The base width is completely filled by the depletion layer only now, because the small width only now. At the time, the majority carriers from emitter to collector are unable to move. They were unable to move only now. The reason was depletion layer will not allow the charge carriers to move to the what now? Collector only now. That's why we need to make the base width very small and collector region we need to make higher only now. If it is higher, depletion layer in the collector will be more possible. Depletion layer in the what now? Base will be what now? Smaller only possible. In that case, easily the depletion, easily what now? Majority carriers can move from the what now? Emitter to the collector only now. That purpose only we are going to use. This is very large, this is very small, as per the early effect only we can say only now. But what are the values are maintained practically? WC, WE, WB you have taken now. What WE is taken approximately in practical application? What is the value of WC is taken? What is the value of WB is taken? They were all maintained. WE or WB or WC must be maintained in micrometers only now. Micrometers only they will maintain. Very small that width. Understand now? I can say approximate values, these are all. WE, W suffix E is approximately equal to, they will maintain 2 micrometers. 2 micrometers, it is maintained this value. That means the width of the emitter region is maintained 2 micrometers approximately. And also the width of the base is approximately, it is maintained 1 micrometer. 1 micrometer it is maintained. This is maintained 1 micrometer one. This is maintained 1 micrometer. What about the width of the collector region? It is maintained. That is approximately, it is maintained very large as compared to the other two, 5 micrometers it is maintained. 5 micrometers. The 5 micrometers means is large as compared to the other two regions only now. Because to dissipate the heat which is so formed at the collector region due to increase of the due to the output current, the power is going to increase, that is to be dissipated. That's why we are using large value only now. So these are the values are required, WE, WB, WC only now. Yes, we got idea. The width, how it is to be maintained in the PNPR, NPN transistor only. And second point, you need to understand one more. Concentration. How that concentration is to be maintained in PNPR, NPN transistors now. Just I will explain clearly, you watch. I selected here PNP, PNPR, NPN, that is our wish, no problem. I selected here, this is the P-type material, this is the N-type material, this is the P-type material I have taken. I selected in this way. Here we are having the 3 electrodes, one is a emitter, one is a base, one more is said to be collector, we know very well. We discussed about the width of the region. I want to discuss now the concentration which is existing in the emitter. I would like to take it as a symbol. The concentration of electrons or holes, no problem. This is Ne I have taken here now. Ne is nothing but the concentration per meter cube we are going to use, or concentration per cm cube also acceptable. The concentration of the electrons in the N-type region is given a symbol N suffix B. I want to denote. The concentration of the holes in the collector region, I wish to take it as a Nc only now. Nc it is required. Ne and Nb and Nc, these are the 3 symbols we have taken here now. Now I would like to know how we need to maintain this Ne and Nb and Nc only now. Once asked in the gate examination, if Ne and Nb and Nc are the concentrations in the PNP transistor, at the time he gave the 4 options. What are the 4 options are given? Ne is far more greater than Nb and Nb is greater than Nc. One more way. Nb is far more greater than Ne and Nb is greater than Nc. Next one, Nc is far more greater than Ne and greater than Nb. Last one is a null. Like this, certain options are given. Which option is correct is asking you now. That's why I wish to say here now, I wish to say which concentration must be maintained practically very large. I will explain here now. Practically what they will say, in the designing of the NPN or PNP transistor, the concentration in the emitter must be maintained very, very large. It is a far more greater only we need to put. That must be maintained very large as compared to the base region or as compared to the collector region. That must be very, very large. So Ne is a far more greater than what? Nb only possible. But the many students will think, sir, it is not correct. Ne is a far more greater than Nb, Nc only, sir. No. Ne is a far more greater than Nb. But the concentration in the base and collector, whenever you are comparing, generally students will think the concentration, the collector must be maintained more as compared to the concentration in the base. That's a wrong 100%. Practically what they will maintain, Ne is a far more greater than Nb and Nb must be greater than Nc is a must only now. That means concentration which is existing in the Nb is a higher as compared to the Nc only we are getting from these conditions only now. Sir, why the concentration in the collector must be maintained less? Means I will explain that point also clearly now. Clearly I will give clarity. Initially I can say NE must be far more greater than NB and NB must be greater than NC required now. This condition must be satisfied only now. In designing the good transistors only we can say that now. The practically what concentration is maintained, what NE value is maintained, what NB will be maintained, what NC will be maintained. That concentration also I will give. From that you can understand which value is maintained practically large. Understand? So practically what they are doing now, NE is maintained, concentration by emitter is maintained approximately equal to 10 power 19 per cm cube it is maintained. Per cm cube or per meter cube they will use now. I have taken here 10 power 19 per cm cube. And the concentration on the base is taken here now. Concentration at the base is taken 10 power 16 approximately equal to 10 power 16. 10 power 16 it is maintained per cm cube. Per cm cube they are maintaining practically. And NC value is maintained. NC value 10 power 15. 10 power 15 per cm cube it is maintained. Now by watching this you can understand now. At the base the concentration is maintained 10 power 16. At the collector 10 power 15 only it is used now. So you got idea, I hope it now. Understand now. Such a way the concentration are used in the transistor designing only now. Understand my point now. That values are given now. But what are the configurations of the transistors are possible? What are the configurations of transistors are used? I want to explain one by one. After completing the configuration of the transistor, I can enter into what now? Different parameters also I will find later now. For the timing, what parameters are required, you please watch. Configurations of transistor. Configurations of transistor. These are all just the basics, the foundation course. In the foundation course, I would like to give the basics of the what now transistor only. I am not entering into the full subject depth only now. If it is gone, analysis of the maximum possible in EDC. In every topic, so many questions are going to arise. For every question, we need to give the what now? Analysis only now. Then you will get the clarity on this subject. Understand now. In the foundation, I would like to give only just the basics only now. There are three configurations of transistors. One is a common base configuration, second one is nothing but the common emitter configuration, third one is nothing but the common collector configuration. These are the three configurations are there now. Just I want to give those three configurations. One is said to be common base configuration. Base configuration. The second one, I can take it as a common emitter configuration. Common emitter configuration. And third one is taken as a common collector configuration here now. Common collector configuration. Collector configuration. Like that, there are three configurations only here possible now. But I want to explain each and every one of the configuration clearly. Every student can understand easily now. Such a way I will give. And what are the formulas are required? From that you can see also here now. I selected initially common base configuration. CB configuration I have taken. CB configuration. But how that configuration is to be taken here now? I selected here PNP or NPN, your choice, no doubt. I have taken one PNP transistor, for example. This is nothing but the output voltage. Across these two terminals, we can get the output V naught. V naught is possible. But the input is given between these two terminals only. This is Vi. This is Vi. This voltage is said to be base to emitter voltage. This current, I would like to take it as a IE. This current, some current will divert this side, that is a base current. This current, I can take it as a collector current. These are the three components, these are the three currents will be passing through the common base configuration. Sir, why this common base configuration we need to use? Why it is required? But each configuration has got its own application. Common base for one application, common emitter for one application, common collector for one application. Based upon that application only, you can select which configuration is required in the use. Without knowing the what applications, we can't understand which configuration is to be taken only now. Without knowing the application, we can't select which configuration is required. But I can say the common base configuration is used to get the to give the more voltage gain and less current gain only. Whenever in practical application, you want to get the more voltage gain and less current gain, power gain also less I want SAR. These three parameters more important. More voltage gain, less current gain, less power gain. With these parameters, I want to get. So what configuration required? You can say common base only now. We can write one point. This configuration gives what? More voltage gain, more voltage gain. It can give more voltage gain. Current gain, what I said, less current gain it can give. But what is that voltage gain, what is current gain, what is power gain? That will come in the analog circuits only now. By using the small signal analysis, they calculated how to find out the voltage gain, how to find out the current gain, how to find out the power gain also we can do. It's not a mistake only now. So all these can be calculated in the analog circuit. Here work is what? The purpose of the what now configuration only now, that is more important. More voltage gain and also what? Less current gain, less current gain, less current gain and less power gain. Less power gain. You can expect one more questions in the GATE or PSU or IES engineering service also. Is asking here now. Common base voltage gain more and current gain less is required. Mean the type of the configuration used is dash common base, common emitter, common collector, all. You can say common base only possible. Understand my point now. But here, in between this emitter and base, there is a junction J1. In between collector and base, there is a junction J2. Each junction can have some resistance only. The resistance offered by the J1 can be taken as a R in, input resistance I can put. The resistance offered by the J2, I want to take it as a R0 value. How it is to be maintained practically? Ri is to be maintained very large, Ri is to be maintained low, Ri is to be maintained moderate. That is very important. What they will maintain? Ri is maintained always. Ri is input resistance is always maintained, is less only possible. Why it is less, you can understand based upon the what now? Mode of operation of the transistor. There I will explain why it is taken less only now. Ri is less and R naught is maintained more only now. R naught is large. That means the resistance, it is maintained at the output side, but at the what now, J2 junction is a large only now. And at the same time, Ri is a less is possible at the what now, junction J1 only possible. That parameter is more important only, we can say. And next one, what is required? The current amplification. The current amplification of the common base configuration is calculated by what formula? That is more important. Current amplification, how to find out? Current amplification factor means what is the meaning? Output current by input current only. IC by IE can be taken as a current amplification factor. I can write one point. Current amplification factor I want. That is denoted by symbol alpha. Current amplification factor is denoted by alpha. What is alpha here? IC by IE is taken as a alpha value only. Collector current by emitter current we will take. That's very important now. IC by IE value. The quality of the transistor is a best or not. If you want to know, means what way it is possible. By finding the value of alpha, you will identify the quality of the transistor is a good or bad only now. If alpha value increases more and more, you think it's so. You can say directly, the quality of the transistor is excellent. If alpha value is decreasing, you think it's so. The quality of the transistor will be decreasing. That's why the quality of transistor is calculated, the quality of transistor is identified by finding the value of alpha value. Sir, what is the range of alpha is maintained practically? Practically, some range is maintained for alpha only now. What range is maintained? That is more important. The range of alpha is maintained practically 0.95 to 0.998. That the range of alpha is maintained. 0.95 to 0.998 only, they will maintain only. Suppose anybody said, sir, I can design common base configuration with alpha equal to 0.9 sir. 0.9 you said means immediately you will be said, you are not an engineer. You don't have any ability to develop the what now, good design. Minimum value of alpha is a 0.95 in practical applications. You are getting the what now, less than 0.95 means the required current gain you are getting now. Sufficient current gain you are not getting. That current gain is a very small. At the time you are not deserved as an engineer, you are not deserved for the work here now. They will immediately inform you now. Suppose anybody said, sir, I can design common base configuration with alpha equal to 0.99999, sir. And immediately the people will get a heart attack only. How you can design with alpha equal to 0.99999? Maximum value of alpha available from the what now common base configuration is nothing but 0.998 only. If anybody designed more than 0.998, you think it's 998, you think it's so. He must be given a Nobel Prize. He must be given a Nobel Prize, I hope it. Because impossible. So far nobody designed only, we can say. Nobody designed. Because, why it is not possible to get that much value, sir? Because alpha value, what now, if you want to increase means the width of the base, you have to reduce more and more, but lesser and lesser and lesser only now. Whenever the width you are reducing, then gain is going to increase more and more only now. Practically, I gave it that base region is maintained 1 micrometer only now. That is the what now, very small value only now. 1 micrometer is a very small. Below 1 micrometer, if you are maintaining, you think it's so. I said now, practically, it is given some parameter now. That base width is nothing but 0.7 sorry, 1 micrometer now. Less than 1 micrometer if you maintain, chances are there now. When the scientists are unable to design the base width less than that value, we are unable to get what? 0.9999 or something. So anyhow, we can design common base configuration with a range of alpha 0.95 to 0.98. This is the general range only now. Understand my point now. But what about the what now here? When the emitter current is passing this side, means because of the what now recombination of the electrons and holes, some current will divert this side, base, this side IC value. Base current is, but IE and IC are measured in milliamperes only. But base current is measured in microamperes only. How the value of that base current is to be calculated? It is a very simple. The base current, whenever you want to find out, you think it's so. Because I said already, IE equal to what I said, emitter current equal to here, what is possible? Base current plus collector current only. IB plus IC is possible. In that case, I will write otherwise in the next page, this is best. I'll write in the next page. But emitter current equal to, we know very well, base current plus collector current only, we know very well. We can write such a way. I'm in need of base current. IB equal to, we can write IC, IE by IE minus IC, we can write only. IE minus IC is possible now. By using the same formula only, we can find. But what is IC means, still formulas are there, we can reduce to know. Later I will give now. For the time being, base current you can measure from IE minus IC value. This way we can find. Catching my point now. That's way possible now. And the next configuration we can enter now. What is the next configuration? Common emitter configuration we can enter now. I wish to do common emitter configuration. Common emitter configuration. Because we got one formula, alpha equal to IC by IE, I gave that formula. That formula you must remember, understand now. Common emitter configuration. But in this configuration, how we can draw the diagram here now? What way we can draw this? That's very important. This can be drawn in this way, common emitter configuration. These are all just foundation, basics only, I'm saying now. Here I am connecting this side, this is a emitter, this is the base, these two are connected this side, this is a emitter, input we are giving here. I want to receive the output across these two terminals. Okay, selected NPN, RPN. I selected PN, NPN I have taken here. But the arrow is given reverse, it is a NPN. If you have taken this side, PNP, no problem. This current is nothing but IC. This current is nothing but the IB. We can say this current is nothing but IE. These three currents will flow in this particular configuration. When we can use this common emitter configuration, we need to know that application only now. Whenever you want to get voltage gain is a moderate, current gain is required moderate, power gain also required moderate. All these three parameters are required moderate, you think it's so. You should use common emitter configuration only now. What I said in common base configuration, when you want to get the voltage gain of the more and current gain of the less is required, I said you try to use common base configuration. Both are required moderate. Many books it is given voltage gain is a more and current gain is a more and power gain is a more, means you need to use the common emitter confidence. That is not correct. Moderate, must. Moderate only, must only now. Why it is a moderate is given now? Why it is not allowed? What now? In the books it is given what now? Voltage gain more, current gain more, what power gain is a more is given now. But a more is given means the comparison we cannot make now. Already voltage gain is a more in the common base I gave it. If I gave the what now current gain, what now voltage gain is a more in the what now common emitter also, means which voltage gain is a more, it is going to arise the doubt only now. It is going to arise the doubt. Voltage gain, when you compare with the common base and common emitter, common base configuration can have the more only now. There is a more. As compared to the what now voltage gain you got from the what now common emitter configuration. In that case, I can't say the voltage gain in the common emitter is a more, I can't say. Why? Means it is a less than what voltage gain in the common base configuration only now. That's why we can write one point here now. In this configuration, voltage gain is moderate. Voltage gain is moderate. We need to maintain this moderate. Voltage gain is moderate. Current gain is moderate. Current gain is moderate. Asking 1 mark questions, mostly this. We cannot neglect these questions. Current gain is moderate and power gain is moderate. And power gain is moderate. Like that, all these three gains are maintained moderate. Now you got idea. When you should use common emitter configuration means you got the application. When the requirement is this, yes, you select directly common emitter configuration only now. Understand my point now. And in this configuration, we need to know what is current amplification factor. Current amplification factor, how we can find in this particular configuration. And also one more point here, very important now. The input impedance maintained in common emitter configuration is a lower or higher or moderate. The output resistance or impedance maintained is lower or higher or moderate. That point also more important. I can write a point in this way. What I can write? Input impedance is, or input resistance is, input resistance is moderate, they will maintain. Moderate. Why it is a moderate? I will explain later now. For the timing, just note down. Is moderate, and output resistance is moderate. Both are maintained moderate only now. Both are maintained moderate. But in common base configuration, what I said, the input impedance must be low required, output impedance must be high required, I said now. Here both are moderate only, they will use only. Understand my point now. And what about the current amplification factor? Current amplification. That current amplification factor means beta. Otherwise, directly we can write Y then now. Y directly we can write these points. What we can write now? That means you want to find out the quality of transistor. In common emitter configuration, we are using the transistor. That quality of transistor is a good or bad, you need to know. By finding the current amplification factor beta only, you can say, is it a good configuration, good transistor? We are using the quality of transistor is a good, otherwise a less, you can say why. That's why based upon the parameter of beta, we can identify the quality of the transistor. What is that beta? Beta equal to collector current by base current we can use. That formula we are going to use. Because shortly useful, alpha, beta, gamma, gamma asterisk, beta asterisk, every parameter will come. Based upon that one, problems will come only now. But a beta, what is the range of beta is maintained? That is very important. The range of alpha, I said already, 0.95 to what I said, 0.998, I gave it. But what about here? The range of beta is maintained 20 to 500, it is maintained. 20 to 500, it is maintained. 20 to 500, it is maintained. Sir, you said alpha is nothing but 0.95 to 0.98, sir. How this 20 to 500 it comes? It's very simple. But you know very well, alpha value can be relation between alpha and beta. Formula is used, alpha equal to beta by 1 plus beta you can use. By using the beta, alpha can be calculated by this formula, beta by 1 plus beta. If you want to find out the beta, just if you cross multiplied, beta can be calculated by alpha by 1 minus alpha, acceptable. Because shortly useful, these are the formulas also. This can be used. So here, when already I gave, what I gave? When alpha equal to 0.95, you take it for example, you substitute in this beta. What beta you can get, you watch it. It comes, 19 it comes. When you are using the calculator, 0.95 is a 19. This 19 is approximately equal to, it is taken, 20 it is taken, practical. I am a very perfect engineer, sir. Yes, 19 you put it. Approximate value, sir, 20 you put it, no problem. Understand now. In the same way, when alpha equal to, you take it for example, when alpha equal to 0.995, you have taken for 99, given already. I gave already 0.998 only now. Yes, you can use 0.998 you have taken for example. But in this case, what now? Alpha value in the same way you can use now. When alpha equal to what? 0.998, whenever it is taken, beta value will come as what? 499 it comes approximately. That is approximately equal to 500 you need to take only now. Understand now. So anybody wants to design common emitter configuration, he has to take an initiative to maintain the range of beta within what values? 20 to 500 value. That if you maintain, it is a good and worthwhile gain only, we can save it now. Understand my point now. Such a way the value of beta is to be calculated only now. This is nothing but common emitter configuration now. Now, I would like to explain what is the common collector configuration. That configuration also I will complete. These three configurations I will do. The next class, just I will draw the full structure and what are the currents, how they will flow and everything I will give clearly now. How the current flow will be done, how the diffusion is done inside and everything I will explain clearly now. The next class. And the common collector configuration I selected here. Common collector configuration. In this configuration, what is to be connected here now? Suppose I have taken here now, collector is to be grounded. Collector is to be grounded here. How we can ground these means, please watch it. This is grounded. This is the base, this is the emitter, the base, this is a collector. This is collector. This is the base. Between base and collector given input signal and output is taken between emitter and collector. So every configuration you must know in electronic devices only. But this current I can call it as a IB. This current I want to denote by IC. This current I can denote IE. These three currents are required. Now required when I should use common collector configuration in our practical application. When we can use? Anybody can give answer? I explained when to be used common base configuration. I explained when to be used common emitter configuration. And easily you can tell when we need to use common collector configuration. Anybody can respond? Any student? Anybody? I will give clearly yours now. But this configuration when we are going to use means when you want to get the current gain of the more, current gain you want to get the more, but voltage gain you need to forget low only now. Low voltage gain and high current gain, if I want to get, what I need to do, sir? Common collector configuration only. But in the common emitter configuration, I said current gain is a moderate, voltage gain is a moderate, power gain is a moderate. In common base configuration, I said voltage gain is a more and current gain is a less and power gain is a less. Here what we can say? Current gain is a more required and voltage gain is a less required and power gain is a less required, means you need to use the common collector configuration. I can write this configuration is used. This configuration gives. This configuration gives. What it can give? More current gain. More current gain. It can give the more current gain, comma, less voltage gain. Not moderate also, less voltage gain only, must. Less voltage gain, less voltage gain and less power gain and less power gain, less power gain. Then you can use this configuration, common collector configuration only now. Sir, if I want to maintain gains such a way, how I should maintain input and output impedances? Is it required high and high? Is it required low values? Is it required moderate values? That point is very important. What I wish to say, when you want to get the more current gain, you think it's so. Output impedance or output resistance must be maintained very less. Output resistance must be less. Input resistance must be high is required. If such a way you maintain, then only I can get the parameters in this way only now. What I said, input resistance or input impedance, input resistance or input impedance is high and output resistance is less. Such a way it is so maintained, we can say. Such a way we need to maintain only now. What about the quality of transistor? The quality of transistor is determined by finding the value of gamma value. Gamma is nothing but IE by IB. By using IE by IB relation, they will find the what now? Quality of the transistor gamma. If gamma value increases more and more, the quality is very good. If gamma value decreases, quality is very bad. That is we can write the quality of transistor is calculated by the quality of transistor. the quality of transistor is calculated by gamma. Gamma equal to, you can put emitter current by base current 1, IE by IB. Output is IE, input is the base, output current by input current they will use. Suppose I divided in the numerator and denominator by IC. I divided by IC, IB by IC. If I divided by IC, you know, IC by IE is nothing but alpha I gave already. IE by IC means 1 by alpha. 1 by alpha again. IC by IB equal to what I gave it already, beta only. IB by IC means 1 by beta. Beta goes to numerator. Beta by alpha I can get. Already I gave alpha in terms of beta, I gave already. Alpha equal to beta by 1 plus beta. So I can write beta by alpha equal to what I can write, beta by 1 plus beta I can write. I can cancel this beta and beta. Finally, gamma equal to what I am getting, 1 plus beta only. I am getting only. So such a way the value of gamma can be determined only, we can say. So I hope the students followed so far. These are all just the basics of the electronic devices and circuits. Tomorrow I will take the structure of the this BJT, and I will give the parameters of gamma asterisk and also beta asterisk, how those parameters will be calculated. I will explain. And also by using the how we can find the collector currents for PNP and NPN transistor. By using the exponential functions, you are going to find exponential functions and leakage currents. You will see in the next class. Okay then. Thank you.